In this presentation, I will demonstrate the independent samples t-test. I'm still working with the same data set. I've added a gender variable. We want to see if there's a difference between male and female participants playing with a real spider. These are arachnophobes, and the real spider represents the anxiety score after playing with a real spider. So in an independent samples t-test, I'm concerned with a few things. I'm concerned with normal distributions, I'm concerned with measurement error, and I'm also concerned with homogeneity of variance. Before I conduct the analyses, I'm going to examine my data. So I'm going to click on Explore, and I'm going to go ahead and reset this. I will bring in my categorical variable as a factor. This is a factor with two levels, male and female. And I'm going to bring in real spider into the dependent list. For statistics, I'm okay with descriptives. For plots, because I'm looking for normal distribution, I'm going to click on normality, factors together, stem and leaf, that's fine. And I'll click on continue. For options, I don't need to worry about this. Let's go ahead and click on OK and see what emerges. So we have 14 male participants, we have 14 female participants. We have a mean score of anxiety of 46.7 for male. We have a mean score of 46.29 for female participants after playing with a real spider. I would also be interested in looking at whether these are skewed distributions or not, and I can see that they are not with my rule of thumb, but I could actually standardize the score dividing 0.14 by 0.597 and discover that this is well within the positive negative 1.96 of a normal distribution. Same thing happens here. Now I can see that these guys are a little bit flat in terms of kurtosis. This might be because I have relatively small sample sizes. I have 14 participants that are male, 14 that are female. That might be the case for that. I'm going to look at my Smirnov-Kolmogorov. Actually, because it's a small sample size, I'm going to look at the Shapiro-Wilks test for normality, and I can see that these are not significantly different from a normal distribution, and I can eyeball that by looking at the QQ plots, which show that we have a little bit of a zigzag, but not deviating incredibly from our hypothesized normal distribution here. So the dots are pretty close to, none of them are deviating incredibly from the normal distribution. If I look at my box plots or box and whiskers, I can see that I have a huge number within my 50th percentile, and the median score is slightly above where the mean would be, but nothing to be too concerned about. I don't have any extreme values, nothing with an asterisk that SPSS is considering to be problematic. So let's go ahead and conduct the analyses. Let's analyze, and let's compare two different means. And this is an independent samples t-test. These are two different groups. I'm going to bring in my grouping variable as male and female. I'm going to define them. Group 1 is going to be, this is going to be male. Actually, I'm going to type in 0, and I'm going to type in 1 for group 2, which is female. Click on continue, and we want to look at this t-test with a real spider. If I click on options, I will see that I'm only concerned with missing data, and I do not have any missing data here. I'm going to go ahead and click on OK. So again, with my independent samples t-test, the output for SPSS will tell me once again that I have a 14 and 14 participants for each male and female. My means are expressed here. My standard deviations are expressed here as well. And I see that the standard deviation for female participants is slightly larger, but nothing too large to be considering problematic. there's a good chance that I'm going to have homogeneity of variance, but I'm going to check that with the Levene's test, which appears in our independent samples t-test box. And the Levene's test is not significant, suggesting that the variance between these two groups is not different. And that's what we want. We want to have similar homogeneity of variance in these two groups. If it were to be different, it would have appeared, I would have been reporting it here, but equal variance is not assumed. We are assuming that we have equal variances, so our t-test that we report is going to be from the line of equal variances assumed. The t-test, I can already see that the t-statistic is incredibly small. Our degrees of freedom now are 26 because we have two groups for which we are accounting for a degree of freedom of each one to remain not free to vary. And we will talk a little bit more about that in class. And we can see that the significance at a two-tailed distribution is not significant. Our mean differences is minimal, and our confidence interval is actually pretty close, pretty narrow for either both groups. So in this case, I would report that there is no significant difference between male and female participants after playing with a real spider on an anxiety rating score. And that would be the independent samples t-test.